So here is another question on converting signed binary numbers expressed in 1's complement form to decimal. So here these are the two signed binary numbers. The first one is 00001111, second one 11110000. So as you can see, the second one is the 1's complement of the first one. So here first, for the first one, it's a 8-bit number. So first we have to assign the weights. Part 3, part 2, part 1, part 0. So we have 0, 0, 0, 0, 1, 1, 1, 1. So these all are zeros. The sign bit is 0 here, so it is a positive number because the sign bit is 0. So first step is the examination of the sign bit. Then we have to just add the respective bit positions where there are 1's. So 1 into 2 to the power 3 plus 1 into 2 to the power 2 plus 1 into 2 to the power 1 plus 1 into 2 to the power 0. So the decimal value equal to 8 plus 4 plus 2 plus 1. So it is 15 or plus 15. More appropriate would be to write plus 15. Okay, then the next one. Again, first step, always it's a better, and it's a good thing, good practice to always start with this, and as you gain more and more practice, you can skip this step and write it directly when you are confident about it. But if you are getting started with this thing, then it's a good practice to avoid mistakes. You start with this format. 2, 1, 0. So the assigned binary number is 1, 1, 1, 1, 1, 0, 0, 0, 0. So first step, examination of the sign bit. It is 1, so it is a negative number. So it is expressed in 1's complement form. So first what we have to do is we have to assign a negative sign to this sign bit weight. So minus 1 into 2 to the power 7. Then for the remaining 1 bits, it will be plus. So plus 1 into 2 to the power 6 plus 1 into 2 to the power 5 plus 1 into 2 to the power 4. And then finally we have to add plus 1 to the result. This is only for 1's complement, okay? 1's complement format. So this is the decimal value. So that is equal to minus 128 plus 64 plus 32 plus 16 plus 1, which is equal to minus 128 plus 64 plus 32 is 96 plus 16, 112. 112 plus 1. So it is minus 16 plus 1, which is equal to minus 15. So the previous one, which was the 1s complement of this, it was plus 15, here it is minus 15. So obviously the results are verified. So use 1s complement to represent negative numbers, binary numbers. So from this result you can verify it. Now an important thing. So this is, this process where I am assigning the weights, I am writing down the bits and all that. It is time taking, but this is for beginners who are getting started with this thing. But if you have some practice by practicing more and more questions, then just by looking at the question, directly looking at the question, you can get a feel that this first signed binary number, just by looking at it, you can say, okay, this is plus 15. The second one is the 1s complement of this, so obviously it is minus 15. No need to do all these calculations. If it is a multiple choice question, if it is a competitive exam where time is very precious, just by looking at the question, you can say, okay, 4 1s starting from this end, so this is plus 15. And in the question it is given, it is in 1s complement form. So okay, this is the 1s complement of this, because the bits are inverted, zeros are 1s, 1s are zeros, so obviously it is minus 15. Directly, no need to do all these calculations, you can directly know this is plus 15, this is minus 15. Okay, so for that you have to practice more and more questions. You need to get acquainted with more and more bit patterns. So when you recognize those bit patterns, those patterns of 1s and zeros, when you practice more and more questions, just by looking at the bit patterns, you can know what is the decimal value, what decimal number that represents. Okay, so for that you need to practice more and more questions. Okay, so this is the second question related to 1s complement to decimal conversion.